Sure. Yes. Okay. Good evening and welcome back, everyone, to FractalU.com. We are excited tonight because we are going to connect the physics to the metaphysics. I mean, the spirituality to the science. I mean, the hard math to the soft visions here. So, as you know, FractalU.com, we believe in having a very rigorous physics and science to accompany our spiritual and metaphysical ideas. And the core, probably the most core spiritual metaphysical idea that we're working with, which is also the title of my book, Origin of Biologic Negentropy, is the idea that implosion, the centripetal force, creating centripetal force, actually, well, Mark, that's your, says creating centripetal force creates self-organization, negentropy, the ability to steer tornadoes, and all the good stuff. So, and this is Mark Rohrbaugh, who's right here with us. And Mark Rohrbaugh is our keynote speaker this evening. And my function here for the first 3 to 5 minutes is merely an intro and then some dialogue. But as I was saying, so we have been working to prove that fractality is the cause of centripetal force in more detailed and rigorous physics and science. And so tonight we're kind of we're hoping to leap to the climax of that conversation, which is to prove or illustrate with some mathematic rigor and detail how fractality causes gravity, which is to say how implosive, non-destructive charge collapse is key to gravity. So that means that we would do what many physicists are already leaning to. There are an increasing, perhaps even a majority of physicists who are beginning to suspect and even say, Andre Linde, for example, that fractality, quote unquote, may be the cause of gravity. We are going further than that. We are saying, no, we have the equations to show how and why it is that fractality, self-similarity, implosive charge collapse, perfect compression, is the cause of gravity. Einstein was very close to that, who said that non-destructive, infinite non-destructive charge collapse is the mechanism of gravity. Einstein was there, but he didn't know what a fractal was. He didn't know what non-destructive charge collapse was. He didn't know what phase conjugation was. He didn't know phase conjugation creates longitudinal embedding and accelerating charge through the center of the pine cone at the Planck dimension sends the charge through the speed of light into longitudinal EMF at the peak of the pine cone, and that allows the transverse electromagnetic wave to be accelerated through the speed of light at the tip of the pine cone through the speed of light into a longitudinal wave. Very conventional, understandable physics, because we know phase conjugation down the pine cone is how you make longitudinal waves. And longitudinal waves are understood and well known to be superluminal, to go through the speed of light. So, and this was a place where Einstein was completely stuck. He was unable to conceive of any light wave traveling faster than the speed of light, which is indirectly why he said that all action at a distance was spooky, because he couldn't understand how longitudinal waves, through being faster than light, create the ability to contain heat at a distance and have action at a distance. So once you understand that longitudinal waves go faster than light, and they allow charge to be accelerated through the speed of light at the center of the pine cone, which is the Planck dimension, suddenly you know where the charge goes after it's been converted from compression to acceleration. And when you know how the charge goes out the bottom of the drain vortex, suddenly you know the way out for charge through the speed of light, which is how charge got accelerated from compression. And charge acceleration is identical to gravity. So we have a very useful, subjective here, description of a mechanism for the cause of gravity, the fractality that is perfect pine coning, the phase conjugation, allowing compression to become acceleration, which create that acceleration of charge towards the center is gravity. So I talk too fast. However, this is the kind of language we have been using to explain how if you get fractal, you get not only centripetal force and gravity, you get negentropy and the only way out of chaos. So you can see that if we're right, this may be some of the most profound physics that's ever hit planet Earth. But obviously, since this is such a profound breakthrough change in the view of physics, oh, we're not condemned to entropy. No, there's a way out, negentropy. Since we have a profound radically new physics here. Fractality causes gravity. The challenge is that our rigor, our mathematics proofs must also be, if the claim is extraordinary, the proof must also be extraordinary. So we are demanded to have a very rigorous proof to show how fractality causes gravity. So this is my passion, and I'm delighted that Mark has seen this and accepted the challenge of this ball. You know, we started on this when we showed that golden ratio optimizes constructive interference, therefore compression, and therefore potentially gravity with our equations. We showed the Klein-Gordon equations?
Yeah.
So we showed golden ratio optimizes compression and constructive interference, and therefore potentially non-destructive compression and gravity. So we pointed to that with our early paper, fractalfield.com/mathematics of fusion, and Mark has now made the connection to his description of the proton-electron mass ratios and ultimately his polynomial showing fractality and gravity are identical. So I won't carry on any further. I've talked way too fast, but that was fun. And now I'm going to turn the whole thing over to Mark, and I'll just have a few things to say in the background to keep it fun. You're on, Mark.
All right. Well, thanks, Dan. That's a good focal point for what we're doing now. You know, you're talking about where we're going with this, basically showing that gravity is an electromagnetic phenomena, charge implosion, ether flow, and that. So I'm coming from the mainstream, as you know, also the far out stuff. I'm going to talk about the full general wave equation solution to a single hydrogen atom. And, you know, the approximate stuff is the Schrödinger wave equation, and that's the solid state reduced. That's what I've studied in college and do for a living, and verified that theory. Meaning, when I worked at Texas Instruments, I was one of the founders of the modeling lab in the mid-'80s, 1980s. They didn't simulate, well, they were just beginning to simulate this solid state stuff. So we used to breadboard this stuff and simulate. We had to correlate our models to these equations. Well, you can take a band gap reference. Now, I don't want to get too technical here. I was going to try to give, you know, we need voltage references. Well, that stuff comes from analyzing this physics, and you can make a voltage reference, take it all the way back to the silicon energy gap of silicon. And so we're only going to be talking about the hydrogen atom, because that problem is tractable. It's analytically solved when you just have a single hydrogen atom, which would be a proton and an electron, a two-particle problem. So a way to really reduce what we're going to talk about today is we're going to talk about reductionism. If anybody is familiar with the Resonance Academy, Harriman and his team, they talk about isolated systems and reductionism in science. Well, that's what the Western mainstream science does, is reduce, break things down. We're breaking the atom down with the Large Hadron Collider to see what the atom's made of. Now, I'm just going to go right into this stuff. I want to set a little bit of background, because instead of just saying, oh, we're going into these deep equations, we're going to just back off for a minute here and refocus on what the problems are we're trying to discuss and solve. And I'll just go over my intro here. The main thing, like I said, I'm going to talk about the hydrogen atom, the solution to the wave equation. The interesting thing is I found a solution. That's what all these papers are about. That's why we're back here making a video and meeting again, because some very precise results came out of this analysis that is missed by the mainstream. So I'll just briefly say what it is. We're focusing on the question of what is mass and what is matter. And we're working on unsolved physics problems. Now, as I'm coming from the mainstream, realizing, oh, there's a lot of stuff we don't understand, this points right towards some new physics. And as I, look at your work and other people's work, it looks like it's fitting right into this, and that's why we're going to work on bridging it together. So
Exactly. And Mark, if I could, just a little context too. So the background here was that, we had been saying that charge compression, that matter is basically when waves of charge get compressed. That's the central hypothesis. And people seem to be comfortable with that mass is basically compressed energy. That's old information. But the perfect compression that enables charge to be compressed perfectly is fractality, is where we're going. So which is kind of the unified field mechanic. Maybe if you turn your speaker down just a hair, Mark, I think that's a little feedback, sorry. Just a hair down.
Maybe if I just that way I had my hand by it. Is that better if I take my hand away? Yeah.
Yeah. I think no, there's a little feedback there. I think it must be but it doesn't matter. It's not critical. So, but to finish the thought. So then the next step was, we took the Klein-Gordon equations to show that golden mean ratio in a generalized wave equation is maximum constructive wave interference and therefore maximum constructive compression, which leads to the next thing that our team discovered, which was that if you take the Planck length and get integer exponents, simple powers of golden ratio times Planck, you get these three beautiful hydrogen radii, and that cannot be a coincidence. So hydrogen is using this mechanism, the golden ratio as phase conjugation, enables it to do the charge collapse, which allows hydrogen to make gravity. So that's our team has put that together. And then Mark came in with his new equation saying, oh, perfect charge collapse is also behind his work on the proton-electron geometric. So take it away, Mark.
Right, yeah, and that's how we're going to tie this in, because when I look at the mainstream, we claim we know almost everything, but there's some things that are missing, and that's what we're going to talk about today. So let me proceed with that, because it'll become clear here, because let me do a little bit of background too. We're going to talk about what is mass and the solution to this single hydrogen atom in the context of the mainstream question that Richard Feynman brought up. And I've mentioned this a lot in my blogs and other talks. Feynman and other scientists, Nobel Prize winning scientists, have pointed out that we really don't know what these terms are that we use, like the fundamental mass of the proton, the electron, and all the constants that we're using in physics. So that's why they have to go measure them. Well, that's science. You go measure it, compare it to theory. Here's what we're getting to. It appears there's a solution to this full general wave equation that mainstream people missed. Now, and I'm going to overview it right now. What they've done is a reduced mass assumption. They take the proton and the electron of the hydrogen atom. Let me go to the next page here. See, that's right. You showed me if you click in the middle. Yeah. So I can just jump to a page. So
you can zoom in, drag around.
Yeah, zoom in and drag around. So here's what we're going to talk about is this is the general wave equation, and if we apply it to a single hydrogen atom. Now, see, I don't want people to worry about math. This stuff has been solved for since the Manhattan Project. These equations are solved, are written about it. And in the 70s, when the quark model was being defined and they're working things out, what they found out is that they can break up this function into quantum numbers, and they separated the angular momentum from the magnetic moment. So there's quantum numbers that cover all aspects of the energy you can have in these particles, all freedoms of motion. However, they've missed a couple things, and rather than talk about what they missed, let's just focus on a little bit of history for perspective, because this will, before we dive into these equations, I have some notes here, and I want to talk a little bit more about the historical perspective to answer this question that we started. That's a big thing, Dan. You were talking about showing gravity from these fundamental first principles. Well, we got to
Yes.
we're going to set some groundwork to show how we're going to address that. And by doing this, any mainstream scientist or anybody listening can join in, because this stuff is not really that hard. It's a little bit of algebra, especially when you say work with what the mainstream's done and correct their errors. But I'll get to the point here, because this stuff's amazing. This is what came out over Christmas and with the discussion with Elizabeth Rauscher. So this reduced mass thing. Now, I want to go the history of it. When I first heard about this was in 1977, and as people know, there's a story about Einstein nodding off. He put a cane on his knees as he's meditating on his problems. He knew if he got right in that point of falling asleep, the answers would come to him. So as the cane would roll off, he'd wake up. And well, anyways, when I first heard about this proton to electron mass ratio, here's where we're going, because the only reason why I'm talking is because of the precise nature of these relationships that people have missed, and it's very important, because I'm going to tie this into the proton to electron mass ratio, how they dropped that out of the equations and made this Schrodinger approximation for a single particle. That's the reductionism. This is what Harriman talks about, reduction. They're reducing two particles down to one. And when we go into it, we're going to find out that the mainstream is basically studying error terms. Now, don't want to hammer them, because there's a lot of good science that comes out of that. But if we back up again and talk about, like I said, historical perspective, how in the world can I give a proper historical perspective when I don't have the true history? And this is where it gets very controversial, because they call these things conspiracy theories. Well, that's just to make people laugh and whatever, because it's turning out that conspiracies are real. It's true. But anyways, what I'm trying to get at is we don't have the truth in the media and the news, and the salaries of these people that do the work depend upon them doing what they're told to do. And so this science works very well, and it produces work. Then you say, why am I even talking? Well, what I heard was through my education. I was in college prep in my high school, and there was two teachers that said, when you get to this, don't believe them. And I'm like, this is what I'm talking about. I'm falling asleep in chemistry class, and the teacher's up there explaining, and I've talked about this in one of our talks. It's Leslie Jackson was the chemistry teacher. He says, yeah, if somebody can figure out this proton to electron mass ratio, an equation for it, we might have some idea what mass is. And he says, here's what they're doing. And let me go down to, I got to go to the next page. So one of the problems, here we go. Some of the feedback I've received from by putting these drafts on academia.edu is that it would be really good if I specifically mention what I'm talking about. So when you get into this proton to electron mass ratio, that is we got to define what we're talking about so that we know about the precise nature of this relationship. The best way I found to describe it is it's cold matter physics at 0 degrees Kelvin, so we can get rid of any vibrations. Now, later on, we got to add all that stuff back in, because that's where the magic comes in. But to define these masses and particles, and that's what we're getting up to, we're going to answer that question that Feynman couldn't answer, and that's why these I'm calling these prematurely myself. These are world-changing papers, because it let me just get to it, because it's self-evident. Okay, so let me go into, again, we're talking about ordinary matter. It's protons is ordinary matter, and one of the most precise physics constants is this Redbird constant. And that's, so here's what I want to talk about so people don't get just going, whoa, he's going on these equations. Well, let's just talk about the Redbird constant just a minute. And by the time we get to the end of this paper, you're going to find out you can order a desktop setup to measure the Redbird constant. It's just a laser, and maybe a spectrum analyzer. You can do that with a prism and different and calibration. But anyways, they claim that the Redbird constant, and this is actually, it's a really good thing. They have it determined to 10 to 12 decimal places, and it's defined by this equation. So, you know, and that's what the equivalent here, instead of an equal sign, I'm using an equivalent. This is because I looked it up, but here's where we got to go a little bit deeper. We got to slow down a little bit and say, what I said, I mean, I know I'm covering, we're going to have to probably do a couple of these, Dan, because this stuff, I'm trying to condense like 40 years of research into 2 hours. So
Yeah,
perhaps.
I mean, Mark, you could maybe help people a little bit by just saying, look, obviously it's true by inspection that when electron collapses correctly, that's what a proton is. So the relationship between the electron and proton, everyone knows by inspection that charge collapse is the geometry that allows the charge that is the electron to collapse into the proton. So that ratio of the mass of the proton electron, it's obviously charge collapse. And so if you knew the geometry that causes the charge collapse, which establishes a relation to the proton to the electron, you suddenly know the geometry that creates matter in the first place. And that's the problem Mark is dealing with here beautifully.
Right,
Go ahead.
Right. Yeah, and that's right. So I'm laying the groundwork to be able to address that problem, because we're actually, by the time we get, not today, but by the time we get through our paper, we're going to be answering also Einstein's question about the superluminal implode that converts from transverse to longitudinal, Dan, because this analysis I'm doing today, here's the reason why we're talking about it, is when I go through this analysis, it points to two things: a solution to the full wave equation that determines all of these masses and these constants without measurement. It's by a computer algorithm, and it agrees with the science. So once we get, what I'm going to end up doing is defining all of these terms, so there's no question anymore, and people will say, okay, and then we can move to the next step, which is answering these questions you're bringing up. So,
and Mark, even to try to help you here, looking in Wiki under definition of Redbird constant corresponds to the energy of the photon whose wave number is Redbird constant, which is the ionization energy of the hydrogen atom. In other words, the hydrogen atom spits out light in certain frequencies, and that tells you its geometry, and that is Redbird, basically.
Right, exactly, and that's what I was going to explain next. Thank you. So instead of saying, oh, it's Redbird constant, we back up and say, what is this stuff? Because remember I said a desktop experiment, you take a laser and you blast it into some hydrogen or some sample, and what you're doing. See, I forget that I got to define, it's exactly what you said. The Redbird constant is the constant that allows you to convert the wavelengths to energy. You know, it's all these, so if we go back to this equation that we had on page 1, right here, this general wave equation, that's what I wanted to get to. Yeah, because this is where it'll get a little bit easier to understand, because I'm going to jump down to some pictures now. So what Dan said is that, the Redbird constant has to do with the energy, the quantized energy transition as the electron jumps from one shell to another. So this equation, when you solve it using the quantum numbers and all that classic approach, that's when you get these, and I'm going to show the picture now. Let me just go ahead here a little bit.
Just to say, Mark, so for the basics or for people, that whenever an electron jumps between electron shells, it only can do so in a whole number of photons. And so if you knew what whole number of photons were jumping between the electron cells of hydrogen, you would know the charge collapse geometry, basically.
Yeah, right. So, and once I get this picture up, I'll talk. Here we go. This is what we want here. Yeah, let me zoom in a little bit. Is there a...
This is why we use the Redbird constant to model the charge collapse in hydrogen and to get to that ratio of the proton-electron mass.
Yeah, there we go. Fit presentation and width. That's the thing I wanted to do. Okay, are you seeing this, Dan, or the...
yes, I think it's clear.
Yeah, okay, so I want to talk about it, though. So what when I talk about the Redbird constant, all these constants, we can kind of forget about that, because what we're talking about is these energy transition levels, the quantum mechanics. So, the mainstream, this is all worked out, so that's why we're talking about it. We're not saying there's anything wrong about it, but we're going to take what they did and take it further, take the science further. So that's what I want to show, is by looking at this energy quanta and just re-examining the equations, there's a more detailed solution, and then it points to this other stuff. So I want to go over what this more detailed solution is, Dan, and then it'll be easier to talk about the where we want to go. So let me go ahead and do this. So whenever you realize what we're describing, what we're working on is the energy, the quantum levels when you're transitioning. The electron bumps from level to level. So this desktop Redbird lab measurement, they actually have to do a curve fit to get all this stuff right. So
it was experimentally derived. They actually did the experiment to see how light bounces out of hydrogen, and then they got the curve fit, and that was the Redbird constant saying, oh, this is the key to the geometry of hydrogen, basically.
Right. So now when we're synced up with it, so let me tell you what I found out a long time ago and what everybody's telling me. Don't do what the mainstream does. That's why they call it squalid state physics. But it works. But I got to get to what the point is. So as I was going through some of these derivations, I check all this stuff out in detail. I look it up for years. And as I'm blogging, look at this second equation. I noted that if I took this Redbird constant divided by Redbird, I get 1. And I blogged about it. Now, Dan, I'm doing this for a purpose. And one guy commented, he says, wow, Mark, isn't that interesting how you plug in, use Google Calculator and plug in the mainstream constants for these, and you get exactly 1. And I was shocked, Dan. I'm like, there's an error. That's why this is so hilarious. Well, it's not, this is serious stuff. This is okay. It's because mainstream tunes their results to match these equations. So what I want to do is say, if you look at the literature, it's really hard to find this reduced mass term, this MR, happens to be my initials. So if I just take the mainstream results, so instead of doing all the math again, I just take the results and plug in what they see. I'm actually doing the problem backwards here. When you come from the field, the wave equations, you derive this Rydberg, and all this Rydberg is the energy transition levels. It's just a correlation coefficient so that you get the energy, the quantum energy level right. So you could call that correlation coefficient, get the quantum energy right. So when you go to test it, most of the stuff we build is solid state. We got free electrons, lockdown protons in a crystal. So they just say, hey, this reduced mass it's actually the product of the proton times the product of the electron divided by the sum of them. Now, this is well known. I don't need to prove it, but if you let mass 1 be the proton, mass 2 be the electron, because the proton is almost 2,000 times heavier than the electron, you can just cancel out the proton, and that's why they say it's the reduced mass is approximately the electron. Well, when they put it in their equation. So that's what the mainstream does, and there's nothing wrong with that. But we have to realize they say, like in the books, that this is an approximation. Now, I go and say that because it's an approximation, some of the investigations they've done is just studying error terms. But let's leave that for now and continue this a little bit further to show you why I have confidence that there's something here, because it'll become clear here shortly. So, if you take no matter which way you go from it, whether I take the existing Redbird and put in this reduced mass, or I go from the full wave equation and rederive the Redbird equation, I'll end up with this equation. Now, let me back up here. Right here, I'm showing this reduced mass approximation, but I'm not going to use it. I go back. I'm not going to use reduced mass. I say, no, I'm going to put in the full thing. Now, here is where I'm bringing it back to 1977, what my high school teachers told me, because once you go from this form, no approximations. What I'm doing, sorry for the little bit of algebra here, because I take this denominator, the mass of the proton plus the mass, I'm going to multiply both sides. Now, remember, this is a preview and draft. Once we get to the full paper, I'm going to have this explained in more detail. But all I'm doing is multiplying both sides by the sum of this. And if you notice, 1 times that, you end up with, then I divide it by MP. So you end up with 1 plus the mass of the electron over the mass of the proton equals this. So let me check. So when I get these equations, notice this is the inverse of the proton to electron mass ratio. Let's look at this for a second. We know the proton is about 2,000 times heavier than the electron. So the mainstream, they just say, this term's almost zero. They drop it out. So we're back to our original equation. So here's where I go nuclear. If somehow I could have the whole audience with me up to this point to know this is a valid equation, that I can get to it either from the Redbird constant definition, or I haven't shown, it's a lot more work and it's already been done, the full wave equation for the 2-particle solution, it's this. Now, here, what I mean by 1977, this is when I woke up on the board. My chemistry professor, teacher, high school teacher, this is in the mid-70s when everybody's talking about quarks. And me and my neighbors are talking about quarks because I was into science even as a teenager. He said, if somebody can come up with an equation for this term, the proton-electron mass ratio, they can solve this problem and maybe get some insight into what mass is.
Which is effectively perfect charge collapse. So effectively,
yeah, right. So Dan, we got to back up and stop for a second, go to historical perspective. Back when this problem was talked about in the 70s, if you wanted to do any numerical analysis, you were lucky to have a megahertz type processor. We have computers today that are 1,000 to 10,000 or more times faster. What I'm saying, I used to salivate, and I wish I had a Cray 1 in 1980 because I worked at Digital Equipment Corporation. I was a computer architect. I knew the computer architects, the Alpha team, and I would go to MIT to the computer architect discussions. I better not go into it too much of what I
IBM
did.
at the time. I was at
Yeah, at the
IBM at the
time,
time. I know the
right?
scale.
Yeah. So what I did is I said, holy crap, this stuff. Anyways, let me get back on track here. So the computers, so let's stop for a second. Here's an equation. If I want to do some numerical analysis, today I have this in my cell phone, by the way. The stuff we're talking about, we'll get to, is in my blog. I program in my cell phone in BASIC, and I calculate all this stuff. It takes about 80,000 loops through BASIC interpreter, half an hour on this phone. It would probably have taken a year back in
Yeah, in those
1980.
days. Yeah,
Yeah.
in those days.
All right. So do you sacrifice a year of your time and energy for some
So
math?
that's why Mark didn't win a Nobel Prize in high school.
Right. So anyways, I actually was programming this stuff in about 1981 for a class. Now here's where it gets good. The professor is feeding us this equation and he's not telling us what he's doing yet. I don't know it's this. And we're doing numerical analysis to figure out this stuff. He doesn't give us this term. And me and the other kids for 3 months are working, and the different equations we converged. We're doing numerical solutions. For just so you know what I'm talking about, I want to scare everybody here. If you remember solving the quadratic equation, I mean, that's one of the things they hammer you with either in high school or college. It's just like a second order. A good one is the Phi equation. Let's say you had x squared plus x plus 1 equals 0. What's the solution to that?
Well, to me.
Yeah, it is, but that throws me for a loop if I have to prove it and show the steps. Oh, if you memorize quadratic equation, no problem. Well, let's say you can't memorize, you don't know any of that stuff. You can use a numerical algorithm to solve it. And that's what I did in my blog. I showed, okay, everybody, look, here's x squared plus x plus 1 equals 0. I don't know anything, but I got a computer today. You crank through the roots and it barfs out the golden mean. And if you're careful, know about number systems. So that's what I'm getting to. If you're careful, know about number systems and use the tools we have today, the computers, you can go check this stuff and see what they did, because we have it at our fingertips again.
But Mark, really, so make your point.
I'll make my point.
Yes.
Millions of dollars. Anyways, here's what you do. This equation, if I take this equation here and put it in, but I leave this term out, it doesn't converge. But if I put this term in, the proton to electron mass ratio, this equation converges. Now, what do I mean by converges? I start with seed values and I calculate every term.
You plug in the numbers.
Yeah, if I have
the real numbers.
Oh, wait a minute. Then I plug in seed values. So let's say you have the speed of light to a couple decimal places, 3 decimal places. You got the mass of electron, a couple. The Redbird, these are all standard physics constants. So you feed in seed values to this algorithm, and it will calculate all these coefficients, the masses, to whatever precision you want. And now here's the beautiful thing about it. Here's where I'm going to get to the point. Was if I lock in, if I take this algorithm, and by the way, this is a detailed algorithm that I developed in the 80s. We have to do a mathematical proof, but let's save that for later. But the numerical algorithm goes through and it makes sure, if you notice, back in the 80s, you couldn't solve this for 2 reasons. One, well, you had to have a supercomputer. 2, they didn't have the next step, the proton to electron mass ratio. This is Harriman's work. I actually derived this without Harriman stuff, as we've talked before. These terms right here are what go in here for the proton electron mass ratio. So This is the beauty of it. We're taking mainstream work. We're taking Herrmann's work, where he was invited to CERN and disinvited, and we're going to be able to bridge this to your work, Dan. This is the foundation, because once I complete this discussion, I'm not going to necessarily want to come back to this, because this stuff it's mainstream science, but this is the launching point for this amazing new fields of gravitational control, 0-point energy, and understanding gravity. So let me get to the point, because
Yeah.
so if you take the Redbird equation, do not make the reduced mass assumption. In other words, don't use this, use the full thing. And this is over the holidays, Elizabeth Rauscher says, yeah, don't do that. Build the algorithm. That's what I have in my blog, and that's what our paper is about. Here's the polynomial. When you put Herrmann's equation in, or my equation for now you get this polynomial. Now this is the polynomial that we're writing. This is the paper, the fourth order 7-dimensional polynomial. The 7 dimensions are just the 7 constants, 2 masses and 5 so we don't get worried about dimensions like right now. That's a different realm, because we're not even to the point where we're talking about the Planck fabric, the Planck dimension stuff. That's because, Dan, I'm going to talk about the mainstream so we understand those terms. And then after a few more lectures and later on in the year, when we have some results, we're going to be talking about the sacred geometry structure of the vacuum and how all that adds up. If you build the proton or electron, whatever, just like, Herrmann's done it, but I'm convinced it's going to be this charge implosion ether flow. Now, one other thing, as soon as we get through this, we're just about, what I'm saying here is, if this is correct, I put this polynomial in the computer algorithm. I calculate these masses, constants to any precision necessary. And I've run it up to 9, 10, 12 decimal places. It agrees with NIST code data to 4, 5, 6 decimal places. Now, where we have big errors is with the proton radius. Now, if everybody that's keeping up with this, Herrmann and Rauscher backed out of this proton charge radius solution, but I'm convinced this is it, because if you take Herrmann's solution, which is the same as my solution, plug it in this polynomial, run it on an algorithm on the computer, it only converges, this equation only converges, and I'll tell what that means, because I go through decimal place by decimal place. Not the computer does. If here's the key. You look up numerical analysis when you solve equations like this. One, I know to infinite precision, 1.00000 pi. I have to have pi to many decimal places. And then the algorithm, it goes through and it checks every variable and makes sure that this equation is exactly met, and it adjusts them until it is. If you don't have this,
Mark, you're saying that the controversial one was the proton radius. Is that the controversy between the Schwarzschild versus the conventional proton from Nassim?
Yes, exactly. So here, if I put in this equation, and now notice this term is really small compared to this. If I put this term in, then this equation converges, gives me all the masses and all the constants like Feynman was looking for. However, I have to use the muonic hydrogen proton radius. Well, I don't have to use it. It comes out. See, that's the beauty of it, Dan. Let me go to the results so that
and what Mark is leading to there is muonic hydrogen basically is the unpacked or Schwarzschild proton, and exactly. the packing of the electrons is what we concluded when we got the golden ratio and hydrogen radii. So both are talking to perfect packing. And remember when Nassim said if you Penrose tile a Planck dimension around the Schwarzschild proton, it collapses to the conventional proton. So it was all about perfected charge collapses. But please go ahead, Mark.
Right. So let's, instead of eggheading out with all the details, let's look at some results. Now, I like to have fun when I do this stuff. So when I blog, I kind of live blog, and that's how this stuff comes to me. I was joking, if you know about what an oracle is, it gives you the answers to questions, but no one knows how. So I'm just having some fun calling it the oracle, but I just told you what the equations are. So I called my program the oracle that does this algorithm. Now I did two cases. One is this green case. So let's look at I'm going to compare two cases here. Again, what the algorithm does is it calculates all these masses and constants. Well, I decided to run two cases. One, I locked down the mainstream constants to the best values they had, run my algorithm, and look to see what it tells me for the proton to electron mass ratio. And lo and behold, it's what you'd expect from the mainstream, luckily. 1836.15267, blah, blah, blah. Now, this is why this has to be peer reviewed, because I'm telling you this is significant. If I use the mainstream numbers in my algorithm and the muonic hydrogen, I get all these things: the speed of light, the electric constant, the Redbird constant, the proton radius, the mass of the electron, the Planck constant. All this stuff comes out with mere seed values in this algorithm. Now, it converges faster the better your seed values are. But let's say, for example, you start thinking that the mainstream is wrong, and instead of locking down the golden values, because they claim they're a Redbird constant, we got that to 10 to 12 decimal places. Instead of locking it down like I did to get the nice green results, I free up everything. When I say I free up everything, I take my algorithm and I say all 7 variables, you are free to be whatever you want to be. I do give them seed values to start, though. Now, and I let that algorithm run. That algorithm does not converge if I do not use the full equation. But if I use the full equation and let everything free up, I get new values for everything, but it agrees with the mainstream up to 4, 5, 6 decimal places. Mainstream has really big errors. 4% on the proton radius. They actually won't admit it, but they have the magnetic moment of the proton wrong. A lot of things wrong. However, we don't need to worry about that because we're just going to move on. So here's what I'm telling you. If I free up this stuff, calculate a new set of constants, these are harmonic. These are in harmony with nature if you free it up, because this is the full solution, no approximation, and it's a numerical iteration, and it's precise. And I've done it in the 90s. I ran it and I threw it away because I'm only good to 4, 5, 6 decimal places. This sucks. Just like when I did the proton electron mass ratio, I'm like, damn, I need a proton radius that's 4% smaller. I must be really bad at math. Or I didn't even want to tell anybody, yeah, look at this equation because I need a 4. I buried this stuff. Anyways, let me tell you what this is. You free it up, calculates all these new things. What does it tell me the proton electron mass ratio is? Instead of 1836.15267, I got 0.070 blah blah blah. I want to tell you why I think this is significant. I'm doing a historical research because you got to look back into the 50s, 40s, get all the data. I found an old paper and someone mentioned this value for the proton to electron mass ratio, the 0.70. Before Christmas, this is how serious I am. Before this previous Christmas, I wanted this on my tombstone, 15267. I wanted to give Harriman credit for all that stuff. And I was pushing it. You never guess what I found out, Dan. I was wrong. Harriman's wrong. This is the new answer. So that's why it's blowing me away.
Well, so basically, Mark is saying that the equation generates the actual values with more precision than conventional physics and predicts we'll eventually prove that by measurement, which is a beautiful thing. And
Exactly, exactly. And then while I'm on it, because it's so precise. What I'm seeing from this stuff is so precise. The next step I said was, wait a minute. Now here's how I'm going to bridge it to what you're saying. So wait a minute. They have some errors, and I have errors in my mainstream perception of what gravity is and charges and all this stuff. Now, how do I leap to that? Let me talk about the single hydrogen atom that we just talked about, and I want to get to that diagram. A proton and an electron. The mainstream claims that proton has a charge of +1 and the electron is a charge of -1. So at a distance, now here's where I gotta zoom out a little bit here, Dan, find my slide here.
where Mark's going now is to say, look, what does this tell us about the geometry of perfected charge collapse and therefore gravity, basically?
Right, yeah, because this analysis, I'm thinking, okay, where is it going to go? It points to, so the mainstream, they say, because that hydrogen atom is neutral from a distance, that +1 charge and that -1 charge cancels out. And we're talking about far field. If I go infinitely far away, zero order, first order, that's true. And that's where here I can talk about what I mean by zero order and first order. Zero order would be like constant. First order would be if I analyze something and yeah, it's directly proportional to that. So that's first order. Second order phenomena might involve terms to the second power. So why I'm going into detail on that is when you look at the electrostatic charge between two neutral hydrogen atoms at a distance from the far field. That's the problem I want to talk about. The mainstream zero order, first order look at it is there is no electrostatic charge between two neutral hydrogen atoms at a distance. Well, if you do a detailed analysis, which I did because when I saw you do not use any approximations at all on this Rydberg stuff, I said, let me try that with electrostatics on two hydrogen atoms. And I'll explain it real clearly. There is a second order net residual electrostatic charge between two neutral hydrogen atoms. And I can explain it real clearly right now. So picture this, Dan. You got two protons. They're 2,000 times heavier than the electron. That proton is sitting here. It's a plus charge. And it has an electron that's buzzing in and out, just like the proton. These are vibrations. So it has its probability orbitals, where it can bing in and out. So if it's at a certain energy, for example, a hydrogen, it's not just sitting there. It's that electron is vibrating in and out. It might be in there's two states it can be in. It might be oscillating between those two states or just staying in one. Now, what I'm getting at here, let me refocus here is
Well, just to I think where Mark is going here, as we've in our discussions, if you look more accurately, as Mark is suggesting, at the relationship between two hydrogen atoms at some distance, that instead of saying there's no actual charge, differential charge between them, you see that there is, in fact, a small amount of differential residual charge between them, and that amount of residual charge we may be able to eventually prove is actually where it goes is creating the gravity that's between them. Is that where we're going with this?
exactly. And if it's not the statics, it'll be the statics plus electrodynamics or one other thing, because I have about 12 different approaches for this. So you're exactly right, Dan. So what I wanted to mention was if you take that proton, okay? Remember, we're talking Schwarzschild radius. It's behaving like a black hole. The proton's a black hole vibrating there. That electron is bouncing on. There is no way that single electron that's bouncing around can totally, it's a minus charge. That proton, that big fat proton, is a plus charge. There's no way that Mr. Electron can bounce around and totally mask that proton. Why? Because he cannot, the electron cannot be in the same position as the proton. He has to be in the same position for 100% charge neutrality. He cannot be. Sorry for using personal pronouns, but I put life in these. These are sentient beings. These electrons. So they have conscious. So, anyways, that electron cannot. So why am I talking about that? If I have two protons plus charge, let's say they're ionized hydrogen, and the electrons are out of the picture, 2 plus hydrogens, even at a distance, those are 2 plus charges. They're repelling like mad. Hey, you bring in its companion electron, make the hydrogen neutral again, and then it looks, okay, there's hardly any charge there, but the electron can't go into the same position as the proton. Therefore, I'm arguing that positive charge cannot be neutralized completely by that negative charge. The only way it can be is if it jumps right into the same position, and it's not. This is the Dirac principle, or other there's, if we're talking bosons like quantum field theory, any bosons, you can just overlay photon after photon in the same position, but we're not talking about photons. We're talking about it will turn out we're talking about photons then, but it's resonant structures of photons, sound or condensed light. But so anyways, let me get back on to what we're talking about here. Because a more detailed analysis of two single hydrogen atoms at a distance shows a residual net electrostatic force, and it's a second order term, and I'm in the middle of deriving that. When I precisely derive it, I have two hydrogen atoms that are 2 particles each. So I formulate it's a 4-vector analysis, and as I'm formulating it, it starts looking exactly like this pinecone kissing charge implosion thing, and that's why I got excited and started sending you the stuff to you around the holidays, so to say we're back on track,
Yeah. And so basically what happens is some of the charge is actually being converted into something. And if that charge is in fact getting accelerated by phase conjugation toward the tip of the pine cone, that amount of charge being accelerated could be the definition of the created gravity. In other words, a little bit of that charge got accelerated, and that charge could be the residual. And if we show the amount of that residual predicts the amount of gravity, then suddenly we have a new model for where the gravity is coming from electrically. Is that
right? That's exactly right. So I've had that vector thing set up for a couple weeks now. I need to solve it. When I was at the peak of my vector analysis skills in college, I could have probably done it during a half an hour exam. But since this, Dan, I estimate it's going to take me, just going to tell you, 10 to 40 hours, because this stuff is so important we're talking about. If we do it right, and if it's correct, we're talking, bridging, answering these questions that Einstein, Feynman, and Herrmann. Herrmann's actually, by the way, got some deathbed notes from Einstein, and deathbed notes, Einstein was telling people some of the stuff, but who was around them? Nurses. They didn't know he was babbling some good. He wasn't babbling. He's telling some good stuff. The stuff Harrimann's been doing over the last couple of years is some of Einstein's latest notes. So what I'm going to do is real detailed checking of these equations, and I tell you, it's showing some very interesting things. Like that's why this gravity effect. So let me just go back to the gravity. This 4-vector charge implosion thing, that's a pretty detailed analysis. Well, let me tell you something else here. I think I have another way to analyze it that real quickly we'll get to the answers. And I'm going to just quickly use one of our earlier discussions. I know not everybody was here for our earlier classes, but earlier class, I was just repeating some of Haramain's work. Here's what I'm trying to say. If we apply to this gravity problem, Dan, you're talking charge implosion. We want to know what gravity is. So basically, one approach we just got done describing is, hey, let's look at electrostatics of 2 hydrogen atoms and fully parameterize it. And even looking at the electromagnetics, because there is a residual force there, but that's one investigation. Here's the other one. We know that when we're calculating the masses of black holes, protons, electrons, and this stuff agrees with your work. If we use, I call it the Haramain technique, it's the information theory and geometric theory stuff. It's how you calculate the masses. And remember, there's an integral equation that was on Sean David Morton's book that I believe is a formal way of writing down the Haramain technique. And I'm going to describe it real briefly for a black hole or a proton, and then say how that same technique can be used to derive gravity, the force of gravity. This is speculative right now because this is a backup solution, but I want to tell you this one because it's really amazing. So if you remember how we calculate the mass of, say, a proton or a black hole, we have a couple of terms. One of them is the information theory thing, and that has to do with the surface area of black holes. This is the Leonard Susskind, Stephen Hawking argument. Entropy of black holes, surface area, loss of information. So we're all in tune with that stuff. Haramain uses that, and what he says is, if you take the equatorial cross-sectional area of the proton or the black hole or the electron, whatever it is you're talking about, so you just write an equation for that, and that's, circle, it's the area of a circle, pi r squared, whatever that is. So you put in RP, the radius of the proton, and the radius of the black hole, and mass. So we're not talking any rocket science. You just do what you should do. Let's see.
So it's the area of the circle, which is the diameter of either the proton or the black hole.
Right. That's one term, and then the other term is the total surface area of the proton or the black hole. Yeah. And you take the ratio of that. So it's the equatorial cross-sectional area ratio to the full surface area of that object you're talking about. Now that is a geometric ratio, and if you remember when we went through all that, when we put the geometric ratio in, and there's an information theory ratio, it had to do with the eta and the r terms, but let's not worry about that right now, because when you follow that technique, you just talk about its surface areas and geometric ratios. Well, remember, one of the big problems was the proton mass came out way too big, but when you do the information correction, then it comes out right, because we're arguing it's analogous to because the mainstream left out the ether. That's a dense, very dense ether. So when you correct for the ether, then everything makes sense. I'm telling you that so that we can get to the next point is, okay, so
we got, so the area of the surface of the sphere versus the area of the circle at the equator, which is like literally from the collapse from 3D to 2D.
Right. So here's the interesting thing, Dan. That precisely gives you the mass of the object you're talking about, like the proton or the black hole. Well, it agrees with the measurements. That's what these other papers that Harriman and other people have done. So once we know that agrees with it, and this is new stuff. It's still being peer reviewed. Some of that work back again. We're talking about calculating masses. That's what Feynman was saying. Not only can Harriman do it, our new approach can do it, and I think more precisely. So here's how I just got done describing the surface area argument. It's the full surface area divided by the cross-sectional area. Now, this will be in a paper later, Dan. The point is when we want to talk about two particles and how they're attracted to each other, it's going to be the cross-sectional area of that proton black hole. It's a drain. So that proton is a drain in the vacuum. The black hole, it's an inflow, outflow. And then you got another proton black hole. It's a drain in the vacuum with inflow, outflow. That's why there's mutual attraction even at a distance, is because these are black holes in the vacuum. Well, if I reduce the fluid dynamics, superfluid dynamics is where we're going. If I want to talk about superfluid dynamics of two black hole protons, all I need to know is the cross-sectional area of these two black holes. So the cross-sectional area of two hydrogen atoms, we precisely know that because we're going to go with the muonic hydrogen radius. You could use the mainstream, get a little bit of an error term, but this was the next step. One of these approaches is going to work, Dan. I know, again, this is why this is a preview. The 4-vector analysis is looking very promising because there is residual electrostatic force at a distance. That's, like I said, well, that's one approach. This surface area approach is the next one I'm going to do. That's actually a faster one. The thing is, I think the equations are going to fall right out of it, because here's the fascinating thing. The surface area thing multiplies by a r squared, a radius squared. When I did my gravitational derivation of electrostatics using the 4-vector thing, I did a real quick one. Instead of getting, for the gravitational law in the denominator, it's capital G times mass 1 times mass 2 divided by r squared. Distance squared. I didn't get distance squared. I got distance to the 4th power, and I'm like, holy crap, I really screwed up. This was with the real quick analysis of now I'm telling you this because that 4-vector analysis, a quick, an r to the 4th, if I multiply that by an r squared, this surface area thing I just talked about, it corrects it. So we may actually be merging both approaches. So
I mean, conventionally, phase conjugation is 4 vectors, originally 4-wave mixing in optics. So the way the 4 point cones converge accurately. And what Mark is saying is that if we then predict that difference in charge between the two supposedly stable hydrogen atoms at a distance, if that the amount of that residual charge predicted one of 2 ways is what Mark is saying. If the amount of that charge difference equals the amount of charge that got accelerated out through the center, that defines the amount of gravity between them. So the equation could predict gravity and therefore prove.
Yeah, and Dan, I think this ether flow stuff, the superfluid dynamics, it'll be like someone who's already skilled in that. There's a couple guys I know, Andrew Murray. I had to get a hold of a couple guys. This has got to be one of those problems that, and the limit is real simple. And I tell you, as soon as I get a little bit of time to go through it, we're gonna have some amazing stuff. Now, let me take this.
Note just a comment.
Go ahead.
That what Mark is saying is that treat the universe as a superfluid, as in the Dewey-Larson famous book, Nothing But Motion. So we're saying charge is the unified field, the ether, and it behaves like a superfluid. It seems like everybody agrees,
Yeah.
including the scene. And also,
Yeah.
just to comment quickly, Mark, Liddy is asking very appropriately in her question, she's saying, would this be considered remote entanglement? And what we're saying is perfect embedding is perfect entanglement, is phase conjugation perfected, is charge collapse. So the reason the one little black hole at a distance entangles the other, the extent to which one black hole at a distance entangles the other at the other distance, which is the relationship between the hydrogen proton, that amount of entanglement, which is literally the suction between the two vortex at a distance, is called gravity. So it is about entanglement, exactly.
Yeah, Jason has it right there. All protons are entangled. That's something that came to me. I tell you, the more you work on this stuff, the more you find out.
We're saying the
and I'm not lightly saying that, Dan. Once you realize what's going on with this dense ether, we're intimately entangled.
Yeah,
so, hey,
and we're saying the mechanism of that entanglement is specifically where the pine cones do kiss noses accurately at the Planck length, the inertia is converted from transverse to longitudinal, and the longitudinal being superluminal enables action at a distance, which is entanglement perfected, literally.
Yeah.
So that's why phase conjugation equals entanglement perfected, which creates a longitudinal, and longitudinal waves then are gravity waves.
Yeah. Hey, Dan, I'm going to fill up my water just a minute. And can you do a little? I'm going to come back with a more discussion. I'm going to do not a wrap up, but a summary, because I did a lot of talking, but this stuff, I mean, look at this damn diagram right here. Looks really scary and intimidating. But I don't want it to be that way. This stuff is already solved. I've all my life I've been a mathematician. I'm going to talk about this stuff. All math is a language. So look at this, like Egyptian hieroglyphics, little birds and stuff. And I mean, for the people who get afraid of math, is what I'm saying, because there's no reason to get afraid of it. Because we're going to talk just a little bit about. I just want to I want to wrap it up to make sense, because here's the quantum numbers and the wave equations here. I want to talk about it because the mainstream trap with the Schrödinger cat argument and all that stuff, it's analogous to the flat earth argument, that it's made to entangle people's minds in nonsense arguments, So
yeah, they said that Schrodinger's cat could not act at a distance for the same reason that Einstein said action at a distance was spooky, because they didn't understand how if you create a longitudinal wave, the superluminal quality enables action at a distance. Yeah, and that's why we went.
Right. So I want to be able to talk about this stuff win-win, because when I approach mainstream people, you should see that. Well, I had to stop being judgmental, because I'm learning a lot. Because it's my own perspective. When I talk to people about this stuff, like one guy said to me, "Oh, you got some new stuff, do you?" Like some. Anyway, I have to let that go. I want to show people that what the mainstream is saying when they talk about the quantum numbers, the Schrodinger's cat, and with a glee in their eyes, they say, "Well, nobody really understands this. Anybody that says they do doesn't know what they're saying." That's true. But I want to be able, they shut people down in the mainstream so much. I want to be able to tell people what this stuff is. So by the time we're done talking about this, Dan, I have to be gentle, but that old statement about insanity, doing the same thing over and over, it will demonstratively be proven. Now, I'll just do a real, so I don't attack the whole world. I'll just say this CERN EU thing, that's unbelievable waste of money and minds. What that is, I mean, I got to take a break here real quick, but what that is, that was supposed to be the answer to the superconducting super collider. However, that was in the 80s, and remember I was talking about historical perspective, and I don't know history. We've been lied to since I'm not going to go into that. But the point is that there's more to it than this, because if you look at what the mainstream's saying, they'll say, well, yeah, of course we don't have it right, but they won't let you look at other stuff. They'll shut you down, laugh at you, or whatever. So what we're going to do is we're going to try to enable people to have enough knowledge to be able to not get shut down. And so,
and while you're gone, Mark, I'll just summarize here. We have the background information from Sal Giandinoto about the golden ratio and the derivation of the Schrodinger wave equation. And the point is that the Schrodinger wave equation is obviously a generalization of how waves interfere. So obviously somewhere in there, if we're right, the perfect wave interference is golden ratio. So Sal's work on golden ratio and the self-organization of the Schrodinger wave equations is almost self-evident. And the other thing, just to say that when we did that whole visual of how the transverse inertia going up and down enters the top of the pine cone, and it's translated perfectly to when it comes out, the kissing of the tip of the pine cone, that transverse has been converted to longitudinal compressional, and therefore faster than light, and therefore allowed to go through the speed of light. And even Einstein would admit that if you found a way through the speed of light, you'd know what gravity is. You could know how gravity got accelerated out the center.
Yeah, so I'll be back in just a minute, Dan, and get a refill on the water. And keep in mind, too, that this stuff is, all this work is, it's tractable, but everybody has a different perspective. So I'll be right back, and we'll do a little summary and wrap up, okay?
Yes,
and if you can
sure.
do a little talk. Okay, be right back.
Yeah. So basically, Mark is saying that the way the electron charge collapses predicts the relationship of the electron to proton, because, I mean, it's self-evident that charge collapse is the relationship between the electron to proton. The electron is a small black hole in a lot of people's language. So the difference between plus pressure and minus pressure for charge is the collapse of charge between the electron and proton. So if you worked out the geometry of that, then you'd know not just what's causing the geometry of the relationship of the electron to proton, but in the process, the geometry of that perfected charge collapse predicts how gravity is created. Because everyone, especially Einstein, agreed that perfected charge collapse is gravity. So that's the one thing. And then later, if you showed that that's precisely related to golden ratio and phase conjugation and therefore fractality, then you effectively have a geometric and mathematical model showing how fractality is a cause of gravity. Because everyone knows, and this is just a review of what we've talked about so many times, everyone knows, and any mathematician knows, that the most important description of fractality is that it is perfect compression. And Einstein was absolutely clear that perfected compression is the description of the relationship of charge to gravity. So what Einstein didn't know, namely that what a fractal is, and therefore perfected compression, eliminated his ability to know what gravity is and to know why an object falls to the ground. So we have lots of beautiful introductory scientific language saying that fractality is the cause of gravity. There are so many scientists that are close to admitting that now. It's a wave that's waiting to crash. All we need now are the equations to prove how it is that fractality is the cause of gravity. And remember, maybe I'll just I'll even turn my camera for just a second here, since we're carrying on. But when in the original conversations, we said so many times that if you look at the top-down view of a pine cone, that self-similarity, idealized by golden ratio, that when the waves converge in the geometry of the perfect pine cone, which is golden ratio, they're adding and multiplying not just the wavelength recursively constructively, but they're adding and multiplying the wave front phase velocities recursively constructively. And when you add and multiply phase velocities recursively constructively, then a portion of that charge inertia, the phase velocity, the front end of that wave, is experiencing acceleration, because what's coming out the tip of the pine cone is a wave that's been accelerated constructively because you can add and multiply the phase velocities. So it's obviously when the wave comes out the tip of the pine cone, it's going a whole lot faster. But how did it get through the speed of light? It's because it's been converted from a transverse to a longitudinal wave, and longitudinal waves are well known and measured to be superluminal, for example, Tom Bearden's work. So suddenly you know how to go through the speed of light, and you know how to open up the drain at the bottom of the vortex to allow charge to be accelerated out at center. And when you open up the drain at the bottom of the vortex to allow charge to be accelerated out, you suddenly know what's causing gravity because you know what's allowing charge to be accelerated. Remember, we're saying the charge acceleration is identical to gravity. So the whole language is ready to happen to say that fractality is causing gravity. The missing piece is simply the equations. And that's where Mark is our hero.
Yeah, and Dan, I was just talking to Liz about it, and this charge implosion, ether flow, it's so clear now. Like, let's look at what mass is. It's a vibration in the ether, condensed light. I mean, depends on how you want to look at it. I don't have it 100% worked out yet, but I've looked at enough stuff that I know. Let's just say that ordinary matter is made up of protons, and we know that is just some sort of energetic vibration in this fabric of space. And by it's when I say vibrating in and out, it's compression. Now, here's the thing. I make analogies. Remember, I write all the time. The analogies, you don't use them 100%. You just use it to get an idea, because analogies fall apart quickly. Like treating electrical current flow as water. That works for like a zero order analysis, but not you have to focus on the phenomena. So the ether flow thing, the gravity, electricity, and all that, we want to focus on what's the phenomena. So in matter, if it's a vibration in the ether, then it's a black hole. I sometimes picture the proton like a little 2-cycle engine, that mass of the proton implodes into the vacuum and then comes back. So it's boom, 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 boom.
And it's conventional physics that the timing of that matter is an illusion in the sense that it's a wave blinking in and out, and it's conventional physics that the duration of the blink is the Planck time and the size of the blink is Planck length. So, perfect collapse through Planck is obvious where the transverse inertia is being converted into longitudinal and therefore superluminal. It's going in through the speed of light by the acceleration. Let's just take 10 seconds here to mention Jan Sisek is with us, which is really cool. He's our partner from London, iThrive.com, and we do a lot of work together. And he, taught Princess Diana her feng shui. But so Jan Sisek is asking the obvious question. He's saying, well, we know that St. Teresa of Avila and St. Joseph of Cupertino and others, the saints managed to levitate. And he's saying, well, you brilliant physicists, how did they do it? Actually, there's a beginning of an answer here, because we know that if you get more electrically fractal than the Earth underneath you, you pay your debt to gravity, which means simply that the reason the Earth makes gravity and the reason hydrogen makes gravity is because it got fractal or got dead. So the Earth and the hydrogen, for example, is fractal, looks like a rose. We proved that. I proved that. And so that it's imploding charge, and therefore that's how hydrogen makes gravity. Now, obviously, if your heart gets more fractal than the Earth underneath you, I mean, it's the beginning of a metaphor that could be physics. We know that implosion in the heart is identical with empathy, compassion, and it was when they were feeling maximum empathy, compassion that they floated. So actually, and we're going to take that later to our propulsion mechanism, where we make this vortex perfectly fractal and show exactly how and why the Nazi Bell and the Vimana flew. But that's the next step. But go ahead. So we do have a clue, Jan. Go ahead, Mark.
Yeah, I was going to say, Jan, I got an answer too. I'm just showing this cell phone here to say this is what I do for a living. Is I've actually designed the chips that go inside of this specific phone, but for all my career. But my wife, I hope she doesn't mind me mentioning this, spent 6 years in an ashram in Brazil. So what I'm just trying to say is, I'm a mainstream guy. I'm open-minded to things. I'm aware of this idea of saints or whoever define gravity and levitating. I know a person who levitated. My wife did. I hope she doesn't mind me mentioning it. But
cool.
So, and knowing that I'm 100% mainstream, well, used to be 100% mainstream. When I come across these things I can't explain, well, I've been working overtime to be able to explain them. So how do human beings on this planet defy gravity and levitate? That's what I understand the question is. Instead of talking about people I don't know, I'll just talk about people I know and how I think it works. Is that okay, Dan, or is that too much to go into?
Sure. And actually, our partner, Valerie's friend, also has a distinct description of levitation in the family. Very real. But go ahead. Yes, exactly.
So I can break the problem into two parts. One is a human doing it. So one has to be in, at least in the where you do it at will, because there could be emergency situations where one might be able to do it at will. But let's say at will, for what I understand, one has to be in very high vibration. And you say, what is that? What's this love energy? I mean, Dan can probably explain this better. And let me turn that off. And
Your heart is phase conjugating, imploding,
yeah. So
harmonically inclusively.
right. So, but then you say, well, wait a minute, how is that going to do it? Well, you have to know what a human being is. So I had to go way back to the beginning to figure out what the hell am I? Because we're talking about matter, mass, energy. Um, uh, when we're saying it's just a vibration in the ether, vibration in nothingness, well, there's consciousness, energy around it. So anyways, if there's really nothing there, there is some consciousness. Yeah, the guy's got right. He's levitating right now. Eric's right.
Yeah. we talk about being lighthearted, and the Egyptians measure the weight of your heart at death, and we know the heart electrically implodes to create empathy, compassion, and obviously, eventually, even bliss in the human blood. These are charge implosion phenomena. So if you take more charge implosion inside your body than in the earth underneath you, you pay your debt to gravity. Walk on water, see God, as the LSD salesman announced at Woodstock.
Yeah. So I think our human body is made up of these energy centers called chakras. That they're real. It's like black hole power. The heart has one. There's a certain number of them throughout the body. Now, this is stuff I've asked other people about, and that's the best explanation I have, because if we are these energy pieces, and by the way, if you lose one of them, you could die. That's how these, possibly how a simple surgery like a liposuction, someone ends up dying. You accidentally suck out one of their critical black holes. Possibly. I don't want to go too far out.
This is the coherence of your aura, which is measurable, which the Egyptians called your ka, your boat into the underworld. And that's what we're saying, is that the capacitance of your aura has coherence, which is your boat into the underworld. But then the part of your aura which sustains acceleration through light speed, which is the ba from the ka, is that which can focus into the longitudinal, superluminal. And when your attention can go there with it, then you can lucid dream and take memory through death.
Yeah. So what I think then is, if a human being here on this planet is in a high vibration in their energy centers, you can actually do all kinds of things. I haven't done it yet. I read about it. I'd like to. But if that's what we are, is energy, then instead of having this technology to do this stuff, we can do it with our own energy centers, like the
Exactly.
heart, mind. Now to me, that's the best explanation of the human part of it. But then what about the mechanics of it? Well, I guess I kind of did a little bit. If gravity is an electromagnetic charge implosion, ether flow, if matter is ether, a vibration in ether, matter and charge is one and the same. It's once you're in tune with your energy centers, you can actually just levitate. Now, what we're going to find out. Remember, I told you about the history. We don't know the history. If some of the stuff I'm reading is true, we already have, well, all this electromagnetic anti-gravitational stuff. There's people talking about it, and I'm like, holy crap, if that's how it works, no wonder it's pretty easy. There's I can't remember the guy's name. He talked about doing some propulsion. He made his own electromagnetic propulsion. It was a guy from Ohio, and the U.S. military got him to demonstrate. This is like in the 60s or 70s, and he was able to do it. So anyways, I'm under the impression that we already have all this technology, and here we are just trying to catch up with the math and without any support, that's why I go after the mainstream, because the funny thing
And that's why
is,
if we model this more accurately to understand how the longitudinal emerges from phase conjugation from the transverse, then we can actually see how our attention eventually can do that interferometry, because we understand exactly how Ingo Swann lit a flame with his mind at a distance in a laboratory through a Faraday cage, measured repeatedly. That's interferometry, longitudinal interferometry. That's action at distance. And ultimately, that's how ghosts move around. In the German war, it was called the Foo Fighters. These were plasma balls, which are moving because of conjugate coherent interferometry, which ultimately is action at a distance, heat containment, all this good stuff. So when we understand the longitudinal mechanics of gravity and centripetal forces, suddenly all these spiritual esoteric ideas about floating become real because we understand the interferometry.
yeah. Yeah, so I find it fascinating. I've had many discussions with my wife, Liz, about technology versus the spiritual way of doing things, and some really heated ones. And the more I'm ready to give this thing up. Well, here's the point, though. Wait a minute. The ancient artwork. It's hard for me to tell the good guys and the bad guys, but I think that you could have a combination of technical devices and spiritual stuff to do the bilocation or the whatever it is they're doing. The gurus, I guess, would be 100%. You wouldn't need technology. So, what do you think about that, Dan? Is there or is this a crutch? That's what I'm wondering, because there's a point where I was really into technology, but I'm starting to think it's a crutch, or is it?
Well, see, the empowerment point of this, once we begin to understand how you astral travel, remote view, take memory through death, lucid dream, which is simply plasma projection, which is basically the definition of temple or Shem unto the Lord, then we begin to understand that our technology was an introduction to what we do with our mind, which was what we have to do to take memory through death. So ultimately, the function of technology is to teach us how to move plasma with our mind and heart, inside out, quite literally.
Okay.
So there are some technologies which actually can teach us self-empowerment, and there are other technologies. Any technology which ultimately weakens your aura is not helping you, because it's your aura that makes you immortal. So that's the thing. We have to use technology to teach people to grow their aura. Very simple.
Yeah. Okay. Yeah. So I think I'm getting in tune now. Like Victor Schauberger, he kind of regretted optimizing those logging chutes because they destroyed the forests. So there's pros and cons to the technology, because what he learned about water by doing that is invaluable, yet it ended up being used. So that's kind of, I want to make sure. Yeah, I want to make sure I use technology properly too, because what I see is inefficient use of resources, and that's what we're addressing with where we're going. We're going to be optimizing systems and materials. There's going to be materials science and optimization of systems and new systems. That's where we're going, and that's why we're doing this work.
Yeah.
That's why. That's why I hammer on the mainstream stuff. Yeah,
you understand the spiritual mysteries like phase conjugate mirrors and Einstein or the Nostradamus' scrying cup and John Dee's showstone. But this is great. But why don't you? We're going to run out of time here, Mark. Why don't you kind of do the conclusion you visualized here? I think there's a briefly.
Briefly. So let me just, before I go and just page through a couple of these things here. I did want to mention this desktop unit. This was pretty interesting. There's a couple of different ones of these, but here's
measuring the Redbird Constant.
Yeah, for measuring the Redbird Constant. So you'll have like a gas discharge tube, like a neon light. You'll have a specific gas in this tube over here.
Just measuring the spectrum of the photons coming off hydrogen. It's
right. And then there's papers written on it, and they do curve fitting, and it's really nice. So that's what I wanted to say, because when the mainstream looks at this and you listen to their arguments, and they're honest too, you got to give them credit for it. They say, hey, if you take these equations, so the wave equation, because I'm getting to these energy, the quantization energy, I'm just going to revisit energy quantization. They said, take this wave equation for the hydrogen atom and find a solution for it for the hydrogen atom. That means they're going to put boundary conditions. That's the thing that we learn when we're solving differential equations or any set of equations. If you set boundary conditions, then you're able to solve the equation. So for example, the mainstream, they come in here, and as they were talking about it and trying to figure out these energy spectra they couldn't explain, they noticed if they broke one of these functions, wave functions, into different pieces with different quantum numbers, and they had products. They took the one function and said, oh, we'll make it a product of this term with this quantum number and that term. They go through the math, do the experiments, and it all agrees within a reasonable experimental amount, and they're just stunned, and that's the birth of quantum mechanics. I'm kind of really oversimplifying it. However, it's shown again and again how accurate it is. It's very good.
But when you get some real measurement that confirms the equation, and that's also related to what Mark was doing.
Yeah, when you keep on going after because this is 180 years ago, when you keep on going, you start finding the cracks in the theory and what isn't quite working out in this proton radius thing. And you work it all. You find out in my opinion, they've fudged a lot of things. However, it doesn't matter, because with these solid state devices, it totally agrees with what they're saying. So we'll hold this up as proof. We know what we're doing, and the rest. And you, Dan, don't mean to attack you, but what can you show? A water imploder? I mean, that's important. But the mainstream people that might not know how important that is, that you get.
I can show a plasma imploder, and the plasma imploder is working commercially in 20 countries.
Yeah, but I'm talking about the guy like me that might not be totally aware of that and say, we do this, you got a water thing. I don't know that improves germination by 60%. I might not know how important that is. Well, what you're doing is really important. I'm saying I've heard the mainstream dismiss a lot of these crazy ideas as crazy when they're not, because they say, we got this, what you guys got. This is an approximation. Elizabeth, when I talk to Elizabeth, she says, don't hammer the mainstream, because that's how we make our living. But I tell you, we got to get some awareness. That was what I was trying to get to, Dan. It's the awareness. Yeah. Because the mainstream say this is an approximation. And if it is, what are they not telling us about? And it's all this stuff that's implied where this is pointing. And this is where the trillions of dollars have disappeared in the secret space programs. And that's coming out this year with the if you know what's happening, you probably know better outside the country than I do from inside, but there's major,
we don't want to go there.
It's a major revolution. Yeah, I know.
Mark, just in terms, if you could zoom in on what you have on the screen here just a little bit. If I just had this intuition too, that if this version of the Schrodinger wave equation, if we plugged in Sal's golden mean ratio derivation of Schrodinger, we could then substitute values and show that in fact it was golden ratio perfect compression behind Schrodinger itself.
Yeah, I got to dig into some of these papers, Dan, because what I'm finding out, like I said, I come from the mainstream. A lot of this work's done. Liz and you point me in the right direction. I'll have to I know you sent me a lot of papers. It's hard for me to keep up because I have a full-time job.
But I'd like to look at Sal's golden ratio. Yeah.
That's what I want to see, because he might actually have it done. I just need to kind of bridge it with a couple of things. Yeah, okay, good. That's why we're talking about this, because I'm learning as I'm doing.
So what we're saying, guys, is all of these things summate to evidence that perfected charge collapse is a cause of gravity and negentropy and all centripetal forces. That's the point. And perfected charge collapse then is what the problem fractality solves. So converting that to golden ratio phase conjugation and equations is what allows us to prove how to perfect charge collapse. And then we can do that in our technologies and emerge into negentropy, as we did in Therapy.net plasma. But now we're going to have 2 or 3 different propulsion technologies to acknowledge, along with the equations for gravity.
Okay, yeah. And that, I tell you, oh, by the way, Liz explained the levitation here in the chat window.
Oh, nice, Liz. I see it. Thank you for that, Liz. So she's saying total coherence. Exactly.
Yeah,
And
in a state of
we're saying that
Good.
we're saying that the climax form of coherence is phase conjugation, basically. And optics is an example of that. You start with climax coherence in lasers, and then you arrange the geometry to make the pine cones kiss noses, called the phase conjugate mirror in optics, and you get negentropy, which we say then is the climax form of coherence. Basically, implosive conjugation fractality is the climax form of coherence.
Yeah.
Exactly, and therefore causing gravity.
Yeah, so my goal, Dan, is to bridge this mainstream stuff through to the work that you've been doing, because I've seen it that, oh, that's what I was say. All this stuff, this looks detailed. We know, like I argued, the geometric ratios, information theory ratios, the universe is geometric. It's multidimensional type stuff. So it's going to simplify, well, when we project our perspective, that's the thing, into this reality, because if you look at, there can be different perspectives. So for example, I look at it from the mainstream from a certain way, then I'm only able to talk about certain aspects of the problem, kind of generalizing it. However, you're going from the detailed Planck thing, and I'm going to get there. You're going to see things I don't see, and likewise, Sal or someone else is going to see things, because we're all looking at the problem from a different angle. But I want to bring it all together so that there's a total understanding of it, because I tell you, when I look at it, it really looks like it's right on the other side of this Schrodinger approximation is all this stuff that makes your work possible. To me, that looks like the delineation is this reduced mass, the reductionism, because they can reduce this equation to something tractable, which is the Schrodinger solid state. You look at all the literature, that's where it is. But if you want real science, real how is nature behaving, you got to include 3D effects. You can't do this reductionist thing.
Yeah,
You know?
and then to summarize, Mark, too, the paper that Mark and I are planning and working actively to assemble right now is going to put together all of the following: our original equations to prove that golden ratio is max constructive interference, therefore max constructive compression, therefore implosion, and 2, my equations showing the golden ratio exact exponent multiples of Planck produced so many important negentropic dimensions, especially the exact 3 radii of hydrogen, exact 2 frequencies of photosynthesis, etc., planetary orbitals, all this stuff. So that was a line of negentropy. So those are the 3 basics. And then we add that to Mark's work showing the geometry of perfect collapse, which was the proton-electron mass ratio, and then his new polynomial, also predicting the fine structure constant. We put all that together to prove perfected charge collapse is the mechanism of gravity and therefore negentropy at a whole new level of rigor. That's the idea of synthesizing all of that in this new paper.
Exactly.
Yes?
And to make it clear how I'm doing it, Dan, or anybody can do it, it's actually pretty easy, because you just summarize tying it all together. But you have to look at this. So we're tying it all together. It's mass. Like I said, anybody can do it. That's what I'm trying to say is, if this if it can be solved, gravity is, like right now, the explanations for gravity are, well, there's really none, or it's
Yes.
So if we can get to the fundamental, that's a fundamental first principle and fundamental constant explanation of it, which you already have the words. I'm going to put from that description the steps here, that show how to go by analyzing a problem, and we derive capital G. That's what I'm trying to say. I've already got it set up. And that's how I check to see if what we're talking about is correct, because the way I'm formulating the problem allows me to derive capital G. And if it agrees with the mainstream, and that's why I'm arguing that this thing will end up proving itself, because like everything we've done, with everything I've done, you need to have peer review, but as the peers review it, they plug it into the calculator and it gives them total agreement, meaning this proton electron mass ratio. That's totally mainstream stuff. It agrees with their work and their experiments, you know.
Mark's work on proton electron mass is incontrovertible. It's totally accurate. And just like my equation for the radii of hydrogen, no one can say it's wrong because it's obvious, it's correct, it's accurate. What needs to be explained is, why does golden ratio predict the radii of hydrogen, which now the new stuff we're doing now will prove. And think what that means. Once we know the cause of gravity, we can do things like arrange systems to emerge from chaos. For example, the Earth grid we know is dodecahedron. If we knew why, then we can finish the task of our ancestors, which is to make the Earth grid more dodeca and thus return atmosphere to Earth. It's about atmosphere mechanics. They called it planetame. And that's only the beginning. If we know the symmetry of wave systems, if we know the symmetry which causes gravity, which we say is phase conjugate golden ratio dodeca, we know why the universe is dodeca as well as DNA is Earth grid, we suddenly can repair it, which means restoring negentropy on a large scale and make propulsion texts. So important.
Yeah, it's so fascinating. It goes from a dead mechanical world to this vibrant living world when you have an understanding of nature. I was talking about the Western mainstream mechanical view. I tell you, I was in that for so long. I couldn't. It's hard to believe, you know.
But the rigor of our work in finishing this task, to do it with such physics rigor that it cannot be ignored from the physics, university, and government world, then gives us the leverage to teach, which is our goal here. So just to be clear. So stay tuned, folks. We are going to have new solid physics paper. We're already in the top echelon at academia.eu. Mark and I, and with Liz's help and Elizabeth Rauscher's help, we're going to finish this task of assembling just what we described, the perfected mathematics to prove how fractality causes gravity, coming soon, and expect it to have just a lot of practical repercussions, even spiritual ones. Yeah. And so unless there's any final questions here or final comments, what do you think, Mark?
I think this is it. Unless anybody has any, we can just look over the questions here and see if anybody has anything new. But yeah,
Eric was saying total coherence via effective charge collapse. Flight, exactly right. So we get the perfect kind of coherence in the aura, which is conjugate, therefore fractal and implosive, and that where you pay your debt to gravity, you float. Later, we're going to show things like, for example, that the accurate spiral of translating inertia on a torus is how the Vimana and the Nazi bell flew, and we have the equations for that, etc. So that we make propulsion technologies based on phase conjugation. And once we understand, it's not just how we replace every form of transport on the planet, it's how you propel yourself in the lucid dreaming, and when you die for the spiral and the torus, it's visualizing the ancient sacred letters. So it gets very powerful. But first, we're going to finish the physics. So we really want to thank you, Mark. Go ahead, Mark.
Yeah, thank you, Dan. I was going to say, as you know, we wrap up the physics, the idea is just to, you know, this stuff is, what I'm working on is just some stuff like the unsolved problems, okay? Because I'm not really, what I want to say is I had so many notes. I wanted to say is that there's a lot of scattered stuff here, but this is the stuff that we're going to condense into a clear, concise thing. I'm just repeating what you're saying, because one of the goals I have is, as an engineer, is if I truly understand something, I can put it on one piece of paper. So my goal is to get to where I can show, because this charge implosion stuff, I mean, everything you say makes so much sense, but I got to get some equation. Well, some of the other people have equations to it. I got to go look at that, because it might already be solved, but if we can inch
We'll
up,
integrate them.
it's a, yeah.
We have the equation for golden ratio on waves. We have the equation for hydrogen. You have the equation for the proton-electron mass. We integrate them, and we show that charge collapse is implied in every instance,
Yeah.
perfected charge collapse.
Yeah. I tell you, it's hard talking to some of my friends too, because to get to these concepts, you have to have the ether back in, and
Yeah,
a lot of people.
but we understand.
Yeah.
The ether is just the compressibility, and the centripetal centrifugal force compression versus rarefaction is plus and minus charge, and it behaves exactly like Mark says, like a superfluid.
Yeah.
But so I think on that.
Yeah, on that note, we should go the yet to define superfluid ether.
We are the superfluid. So thank you, everybody. Thank you, Mark. So we will be releasing this video very shortly, within 2 days. And then shortly thereafter, Mark and I will have this paper, academia.edu, published on fractality and gravity. So thank you, Mark, so much. Thank you, Liz,
All
for
right.
help.
Thanks, everybody.
Thanks,
Dan. I'll talk to you later.
All your friends for coming. It was wonderful to meet all the friends here again tonight. Come again. See you next week. Take care. Bye-bye.
Yeah, thanks, everybody, for showing up.
Yeah. Bye-bye.
Okay, bye, Dan. I'm going to hang up now.